the A7000 magnesium oxide structural insulated panels. It is the most economical seismic shear walls that can withstand earthquake with magnitude 8 and above and typhoon winds up to 330 kilometers per hour. The need for unaffordable earthquake-resistant structures. Earthquakes are devastating natural calamities which kill thousands of lives, destroy properties, and disrupt life-sustaining services and societal functions. Countries along the Pacific Rim, described as the Pacific Ring of Fire or Circum-Pacific Belt, are particularly prone to earthquakes, most particularly the Philippines. Since 2000, the Philippines experienced 20 major earthquakes ranging from magnitude 6.1 to 7.6. In 2004, a joint study by the Philippine government and Japan International Cooperation Agency reported that if a 7.2 magnitude earthquake hits Metro Manila, about 40% of the residential structures will collapse, potentially killing more than 30,000 people and injuring over 100,000 people. Due to the high stakes of lives, building infrastructures, and service disruptions, it is crucial not only to mobilize emergency preparedness initiatives and disaster drills, but more significantly to build affordable earthquake-resilient structures for new homes and facilities in Metro Manila and across the nation. This is the A7000 SIPs. It is being produced in a warehouse in Giginto, Bulacan. I would like to share with you the shake table test of the structural insulated panels that was able to withstand 8.8 G ground motion acceleration. A 1 G ground motion acceleration is equivalent to magnitude 9 earthquakes. So in other words, 8 G has never occurred in the history of man. Only 1 G occurred. So let's watch this YouTube videos of how the structural insulated panel withstand this 8 G ground motion acceleration.
As we've just seen, earthquakes can destroy property and lives on all of the world's continents, and often developing countries are the least prepared and the hardest hit. A unique construction material, it's cheap, lightweight, energy efficient, impervious to mold, mildew and even fire, was how the material stood up to earthquake. With everything in place and a thumbs up from Gary to the control room, the first earthquake begins to rumble. Normally, the tops of the screws that hold the panels in place pop off under these kinds of stress, but even with 50% more acceleration, the house is standing firm, to Gary's delight.
So you got up to 1.1 G ZPA, peak acceleration. We're going boldly where no man has gone before.
The third test goes even further.
Look at that, 1.83 in the vertical.
After 2 more shakes at increasing power, it's not the house that's at risk, but the table the house is standing on.
And that was our last test.
That's what's happened. 8 Gs, really. It amplified that much up there.
The recent event off of Sumatra, they talked about how that changed the shape of the Earth and slowed the rotation down by 2 microseconds or whatever it happens to be. These forces, if they had been in the Earth, are, an order of magnitude above that.
As we've just seen,
So the advantages of the A7000 MGO SIPs. Number 1, it can withstand earthquake forces over intensity 7 without rebars in concrete. It can support up to 3-story structures. It can resist typhoon winds up to 300 kilometers per hour. It has over 4 hours of fire rating. It is also water, mold, and termite proof. No toxic ingredients, will not decay, and affordable. Now let's go to the construction methodology of our A7000. The first thing that we need to understand is that this is anchored either by J-bolts or by Dynabolts to the concrete slab. And this represents the wall. And let me show you more on this. So this is a typical wall connections where we have all the C channels on the bottom, on the top, and on the sides, and the C channels connect the two boards together. And we're using different types of C channels depending on the requirements or the insulation that is required by the customers. This is a typical wall joint. So we have a particular wall, and they will be connected by the C channels together, and the next wall will be inserted inside. So this is an example of a T-wall connections and a right angle connections. In connecting the wall to floor joists, this is a details of how the installation of the floor joists into these A7000 panels. On a typical window section detail, so you will have an opening and then there would be a header above. And for the details of this, let me just show you the next slide where you could actually see that this is where the window opening is. So if we cut it through here on BB, you could actually see that there is the window header above the window, and this is the window opening. And then on the lower part is also the A7000 SIP panel. For the typical door details, where there is a door opening here, and there would be two panels on both sides. So a typical setup is there is again a header that is above the openings, and the door is below the header. For the electrical wiring, we can see that the wires are actually embedded inside. All the electrical chases are flush on the inside of the wall. And all the wirings are actually laid inside and nothing will be seen. Look at this detail. So the wirings will actually come from the bottom, and wherever the plans of the electrical outlets are located, then these wires are brought in there and connected together. For the mechanical, like water and sewer lines and so forth, you could actually embed those pipes within the EPS portion. So that's it. Thank you very much for your interest.